Hi everyone, welcome to this lecture. So this lecture is a continuation of our previous lecture, which was on backpropagation. However, in this lecture, we will cover the step 2 of a backpropagation. That is, we will move from the hidden layer to the input layer, and we will update the weight, which is WJI. So let's start this lecture. So basically, we have to update the weight. That weight is present between the input layer and the hidden layer. But we have to start from the error, because the purpose of each weight updation is to remove the error. Therefore, we have to start from the error and we have to reach here, that is the weight which is present between the input layer and the hidden layer. So let's see how many steps we need. If you remember, in the previous lecture, we moved from the output to the hidden layer and we update this WKJ. In that updation, we need 3 steps. That is, we started from error, we move from error to O of k, then net k, and in the third step we reach here. But here, if we start from the error, which is a necessary step, and if we have to reach up to WJI, which is the weight between the input layer and the hidden layer, we need 5 steps, as you can see here. So this is the equation of rate of change of error with respect to WJI. So basically here we have to reduce the error by updating the weight WJI, which is present between the ith layer and the jth layer, that is between the input and the hidden layer. Okay, let's start from the error and we have to read up to WJI. So here we have an error. So we will move from error to OK. This is our first step. You can see that DE by DOK. Then from OK to net K. So DOK by D net K. Then from net K to OJ. That is, after net K, we will move directly to the OJ. So we will not include WKJ in this equation, because that equation is only for WJI, which is the weight which we have to update. Okay, from net OK, we will move to OJ, then from OJ to net J, and from net J to WJI. So we can see that from DE by DOK, then DOK by D net K, then this is another gradient, that is D net K over D of OJ. In that way, we start from error and we will reach up to the required weight which we have to update. So here we can see that we need 5 steps. So that is the back propagation for us, that if we are far away from the error, so for those layers which are away from the error, we need more steps in order to reach that weight. So here we have 5 values which we have to calculate. If you remember, in the previous lecture, we had only 3 derivatives or 3 gradient terms. Here we have 5 derivative or 5 gradient terms which we need to update. Okay, let's see how we calculate these 5 values. So luckily, what happened? We have already calculated this value and this value, that is first 2 value, in our previous lecture, that is when we moved from the output layer to the hidden layer. It means now we need only 3 values to calculate. So let's start with D by DOJ of net K. So first of all, we should know what is net K, or what is the equation of net K. So in the lecture of the forward propagation, we learn how to calculate the equation for net K. So that is the equation for net K, student. If you remember, that is the equation which we obtained during the forward propagation. So we have to take the differentiation of that equation with respect to OJ. Since our variable of differentiation is OJ, therefore this BK is a constant quantity and its derivative will be 0. Similarly, this OJ with respect to OJ will give us a 1. So we are left with only WKJ. So the derivative of this term, or the solution of this term, is WKJ. Next, let first calculate this term, that is the rate of change of net J with respect to WJI. Also, in the forward propagation, we learn how to calculate the equation of net J. So that is, student, the equation of net J, that is WJI XI plus BJ. So if you do not remember, you can go back and see the lecture on the forward propagation, where we learn how to write the equation for net K, OK. Also, we learn how to write the equation for net J and OJ. So this is the equation for net J. Here we have to take the derivative with respect to WJI. So the variable of differentiation is WJI. So for this BJ becomes constant and its derivative will be 0. And since our derivative is WJI, so WJI and WJI will give us a 1. So we are left with only XI. So the derivative of this equation with respect to Wji is only xi. So we have calculated these terms, and here we are not calculating this right now, and we will call it f prime of net k. Let's see. Now it's time to put all these values, all the 5 values here, so that we can get the value of rate of change of error with respect to Wji. So the first value is dE. If you remember, the first value is dE by dok, and second is dok over d net k. So we know that from our previous lecture. So this value is, the first value is minus tk minus ok, and the second value is ok1 minus ok. Here, for the third value, this is our third value, d net k over oj, and this is our fourth value. So remember, this is our fourth value, this is our third value, wkj is our third value, and this is our fourth value, and this is our fifth value. So now we have already put these two values from our previous lecture. Now for this value we will put wkj, and for the last value we will put xi. So here we have put wkj, and for the last value we have put xi. For the fourth term, we are not going to calculate anything right now. We have just replaced it by the derivative of net j. So basically it is, if we go back and see, this is a rate of change of oj with respect to net j. So basically oj is the activation function, and we have to take the derivative of that activation function. So we are going to represent it by f dash net j. Okay, now these are all the 5 values for the back propagation in order to update the weight Wji. So first 4 terms will becomes delta j. So that is the error signal. If you remember, in the previous lecture, the error signal was delta k, and it was these 3 terms which were included in the error signal. So here the error signal is large because we have 5 terms. So if we write this equation in terms of error signal, so we will get minus here. For all these terms, we have delta j, and then we have xi. So this is the value of rate of change of error with respect to Wji, and here delta j is the error signal which has this large value, and xi are our inputs. Now, after calculating the rate of change of error with respect to Wji, it's time to update the weight. So the weight updation equation is same as we saw in the previous lecture. The new or updated value of ji is equals to the old value plus the learning rate times the gradient of error with respect to Wji. Now put this value. So if we know from the previous slide, this is the value minus delta j xi. So put this value here. So we have plus minus minus, we have learning rate, and in place of rate of change of error with respect to ji, we have delta j xi. So in this way, we can see that the updated equations are same for every kind of weight. Only this is the most important term. We use the same learning rate, we use the same equation for update the weight. But this term is important. Every time for every kind of layer, we need to calculate the error with respect to the weights. So in this lecture, we learn how to calculate the weight that was present between the hidden layer and input layer. Since that weight was far away from the error, we observed that we needed to write 5 gradient terms. And it was a big equation which has 5 gradient terms. So we calculate the value of all the 5 gradient terms. We put the value and find the value of rate of change of error with respect to Wji, and then we update the weight with the help of the gradient error, learning rate, and with the old value of the weight. So I hope you understood this lecture. I hope you understood now the concept of a back propagation. In the previous lecture, we completed the first step of the back propagation, where we moved from the output layer to the hidden layer and we updated the weight wkj. In this particular lecture, which was the step 2 of the back propagation, we moved from the hidden layer to the input layer and we updated the weight wki. So I hope you understood now fully about the concept of a back propagation and forward propagation. Thanks for listening, and I will see you in the next lecture.